In this video, we're going to be talking about antiderivatives, and antiderivatives are really pretty simple to understand if you have a very comfortable understanding of derivatives in general. And the main idea of antiderivatives, or simply integrals, which you're going to be calling them, is that they're essentially just, well, let me phrase it like this. If I had f of x equal, x squared, and we could differentiate this and we could say f prime x equals, 2x, right? So, we can take the derivative very easily. But what if I gave you this? What if I said, hey, f prime x equals x squared, find me f of x? Well, that's where it's a little tricky. And this is definitely a question I thought of myself when I was taking Calculus 1, is when I was learning derivatives. I was going through it, and towards the end of the chapter on derivatives, I think it was like the end of chapter 3, or like approaching the end of like chapter 4 or something like that. I remember just thinking, hey, is there a way to find out what is this the derivative of? Like what, like is there a way to be given a derivative and say, and find out what it's the derivative of? So that's really the idea of an antiderivative, is we want to know what's this the derivative of? So what function is this the derivative of? The deriv. I'll just say deriv for derivative of. And to find this, we take the antiderivative, or the integral. So we're going to take the antiderivative. And that's really all it means to compute an antiderivative. You do the reverse process. You do the reverse process. So, before we just tackle this one head on, I'm going to introduce one of the main rules for antiderivatives. So recall that if I was differentiating, if I differentiated x to some power n, then remember that became n times x to the n minus 1, where you bring the n down and then you subtract 1. Well, now, let's say I was taking the integral, or the antiderivative, and I'm going to be using them synonymously in this video because it just makes it a lot easier. So let's say I had the antiderivative of x to the n, or the integral of x to the n. Either way, interchangeable. Then what you do is you add 1. So you add 1 to the power, and divide by the new power. And then you just add some constant c. And that's all you have to do. So let's give this one a shot. Well, if I have x squared and I want to find the antiderivative, because remember, I'm given the derivative and I want to ask myself, hey, what is this the derivative of? Well, in order to do that, I'm just going to compute this. So I'm going to add 1 to the exponent. 2 plus 1 is 3. So 2 plus 1 over the new exponent. So over 2 plus 1. And that's just going to be x cubed over 3. But you have to add a plus c value, plus c, where c is an arbitrary constant. And you may be thinking to yourself, well, why is this c value even necessary? Well, the c value is necessary because think about it like this. If I was given, let's just say let's say f prime x equals, I don't know, x cubed, okay? Then the derivative, or the antiderivative of this, we could just say it's f of x equals 1/4 x to the 4th plus 5, right? If I take the derivative of this, you bring the 4 down and then you subtract, I get x cubed, and this 5 would go to 0. Well, I could even argue that the original function was 1/4 x to the 4th plus 17. So, if I differentiate this, I would get right back to this. These would both lead to the same place. And one more time, if I had 1/4 x to the 4th plus, or let's just say even like minus 999, if I differentiate this, that 999 goes to 0, and that 1/4 x to the 4th becomes x cubed. So you can see that all of the constant values, they can be differentiated to get x cubed. All of these guys will differentiate to the same thing. So that's why I add the plus c. That's why the plus c is even there, because by adding that c value, you're automatically handling all of the constants this could possibly be. So that c value stands for all of those potential constants that we dealt with earlier. So definitely remember the power rule for antiderivatives, just x to the n equals x to the n plus 1 divided by n plus 1 plus c. And I'm really going to be going over other antiderivative examples as we move along. This is just really the most basic one you're going to see. And computing antiderivatives, you won't have to memorize a whole bunch of formulas and everything. It's really quite simple if you already know derivatives. You'll just be looking at a function and you'll think to yourself, well, what is this the derivative of? And from there, it should be pretty easy. It just requires a little bit of thinking. So let's just dive right into an example and we'll give it a shot. So let's say I had f of x, okay, equals 6x to the fifth minus 8x to the fourth minus 9x squared, and I'm asked to find the derivative, or the antiderivative, sorry. So if your function, is just given like f, no f prime, or f double prime or something like that, it's just given as f, then the notation is that your antiderivative is the capital version of that. It's the uppercase function, so it's going to be capital F of x. And this big F stands for antiderivative. So okay, well, let's just use the power rule. So remember, I add 1 to the exponent, 5 plus 1 is 6, and divide by the new exponent. Okay, we'll do this again. 8x to the 4 plus 1 is 5, and divide by that 5. Okay, and we'll do one more time. 9x to the 2 plus 1 is 3, divide by that 3, and don't forget the c value. And then now let's just clean this result up. So I'm going to get x to the 6th minus 8 fifths x to the 5th minus 3x cubed plus c. And that's it. That's really all there is to it. So it's really pretty easy. And again, if you wanted to leave this 8x to the 5th over 5, that's fine. You could leave it like this as well. I just like to bring the constants out front, and leave it as 8 fifths, but you can leave it as 8x to the 5th over 5, doesn't matter. So this is just a simplified way of writing this, and you can see, this is already pretty easy. There was no tricks to it. It's just pretty straightforward. So now let's try another one. Let's try a different example. So let's say I had f of x equals secant x tangent x minus 2e to the x. Okay, well, if I'm asked to compute the antiderivative, I'm going to write the uppercase version of that. And then now this is tricky, we can't really apply a power rule, but we can do some thinking. We don't need to memorize a whole bunch of formulas. We can just think about this. So look at this guy right over here. Look at that, this part right here, and think to yourself, well, the derivative of what gives me that? The derivative of what gives me secant x tangent x? And the answer to that, just to save time, it's just secant x. And you can always go back and double check your answer. So if I differentiate secant, then I get secant tangent. So I know I did this right. So all I did was I thought to myself, hey, this is the derivative of what? And I just thought to myself, well, hey, that's just secant. So now let's do the same thing. So the derivative of e to the x, the derivative of what is e to the x? So the derivative of what function is e to the x? And the answer is just e to the x still. And this constant, it doesn't matter what it is, it'll stay out front. So minus 2e to the x, and then plus a c value. And again, if this was a 7 secant x tangent x, if this was a 7, then there would be 7 secant x. The constants will stay there. So you can leave them in, it doesn't matter. So this will be my final answer. Secant x minus 2e to the x plus c. So you can already see this is really easy. There's not many formulas to memorize. It just requires a little bit of reverse thinking, that's all. So now let's try another example. I'm gonna clear the board really quickly. Okay, so let's say I had a more difficult one. F of x equals e squared. And it's not necessarily difficult, it's just a little weird to think about. So, well, think to yourself right now, what happened to constants when we differentiated them? If I differentiated like 5, then that just became 0, right? Well, if you take the antiderivative or the integral of a constant, then that just becomes 5x. So what happens to constants when you take the antiderivative of them is they stay there, but then you tack on an x after them, or whatever variable you're dealing with. So if this was a y, it'd be e squared y. But since it's x, we're dealing with e squared, and then we tack on an x, so times x, and then plus c. And, you know, if you want to write this as x e squared plus c, that's fine. It doesn't matter. And you may be looking at this, and, this e squared might not come off as a constant at first. That e squared looks more like a variable because of, e. But remember, e squared is just some number. It's just a number, hence it's a constant. So if I take the antiderivative of that, all I have to do is just tack on an x after it, attach an x to it, and then add my c value, and that's my answer. And if you want to prove this to yourself, take the derivative of this. Take the derivative of this guy right here. And if you take the derivative of big F, you'll get to little f. So, derivative of x e squared is just e squared. This constant will go to 0, and I get e squared as my result. And that's it. So, a really, really easy process. Okay, so now let's try one more example. Or actually, I have a couple more examples. Okay, so let's say I was given f double prime x equals 20x cubed minus 12x squared plus 6x. And I was asked to find f, so I want my f function. So in order to find f, well, I first have to find f single prime, because I'm given f double prime, but I want to find just f prime. So okay, so in order to go backwards, if I wanted to find f triple prime, I would take more derivatives. Fourth order derivative, I would take another one. Fifth order derivative, I would take another one. But if I want to work backwards and find f prime and eventually f, then I need to start taking antiderivatives or integrals. So, this one's pretty easy. We'll just use the power rule. So 20x to the fourth divide by 4 minus 12x cubed divide by 3 plus 6x squared divide by 2. And that's just going to give me, it'll give me 5x to the fourth minus 4x cubed plus 3x squared plus c. And I'm getting really close to the edge right there, but that's the first part. So this is the one we're looking at. This is just a cleaned up version. Okay, so now 5x to the fourth, and now I have to integrate this again, or find the antiderivative of this again in order to find f. So I want to do that one. So, okay, so I add 1 to the power and then divide by it. So 5x to the fourth, add 1 to the power, 5, and then I divide by it. So that becomes 5x to the fifth divided by 5. And you'll see that that just becomes x to the fifth. And I'm going to kind of streamline this process now. Just to save time, I don't want to have to rewrite it. So, x to the third becomes x to the fourth, then you divide by the 4, and that's just x to the fourth. Okay, and then that 3x squared, you add 1 to the 2, that becomes 3, divide by the 3. Those 3's cancel out, and I get x cubed. And then that c, remember what I said about any constant. That c is just some constant. So whenever you have one, you just tack on an x value after it. And then you have to add a regular constant value, another one, because whenever you take an integral or an antiderivative, you need to just add on a constant. So that c became a cx, but now I need to add in some other constant. And I'm just going to call it d. And I'm not calling it c because I already used the variable c. If this was b right there, then of course that could be c. But because I already used c, I can't use it again. So I'm just going to call this d. And that's my answer. So it's x to the fifth minus x to the fourth plus x cubed plus cx plus d. So really straightforward process. And this one just required a little bit more thinking. But not too bad once you get the hang of it. So okay, let's do one more example. Let's just do one more example. Okay, I'm gonna clear the board right here. Okay. So let's say I was given so f prime x equals 4 over 1 plus x squared. And in addition to that, I'm given f of 1 equals 0. So I'm given f of 1 equals 0. So let's first find f. So I'm given f prime. I'm given f prime right here. So I need to find f. And in order to do that, I have to take the antiderivative or the integral. So f is equal to, well, this may not look familiar at first, but if I just bring that 4 out front and I write it as, let me do it over here. If I write it as 4 times 1 over 1 plus x squared, then this should look familiar. This part right here in red should look familiar. And this is a very common integral when you move on to Calculus 2, so I recommend that you remember it. It's just 1 over 1 plus x squared. Well, that's the derivative of what? And the answer is just tangent inverse, or inverse tangent. So this would become 4 tangent inverse x plus c. So the reason that is because this 1 over 1 plus x squared, the derivative of inverse tangent is 1 over 1 plus x squared. So the integral of this is tangent inverse, or inverse tangent. And that 4, that constant just stays along. It just stays along for the ride. And then I add my c value. And so we're not done, I can't just box this answer quite yet. But what I can do in order to be able to do that is I need to plug in this 1 and this 0. Reason being is whenever you're dealing with these antiderivative problems on like your homework or in your test, you'll do what we did before, but if it gives you this other task, it says like f of 1 equals 0 or something like that, that means it wants you to find out what that c value is. It wants you to identify what this c value really is. So all we have to do is we just have to set this equal to 0, and we're plugging 1 in for x. We're plugging this 1 in for x. So we're setting it equal to 0 because this f of 1 is equal to 0. So I'll do 0 equals 4 inverse tangent of 1 plus c. And then 0 equals 4. Well, inverse tangent of 1 is just pi over 4 plus c. And you'll see that those 4's cancel. And I get 0 equals pi plus c. And c is going to be negative pi if I just solve for c. So now my final answer, it's going to be what I had before, but now I have a value for c. So it'll be f of x. F of x is equal to 4 inverse tangent. And then instead of that c, I'm just going to put negative pi. So you could say plus negative pi, but I'm just going to say minus pi. And all I did there was I just specified what that c value was. And that's all there is to it. And I'm going to make another video on antiderivatives and everything, so stick around for that. I just want to keep this one short and to the point. So I'll have another video up very shortly on antiderivatives and more examples on it.